In order to understand electricity, it is necessary to understand something about atoms. All matter is made up from atoms, which are built in turn from a number of subatomic particles, namely negatively charged electrons, positively charged protons, and neutrons. An atom is the smallest part of an element that still retains all the characteristics of the element. The Bohr model, developed in 1913, considers atoms to have a planetary-like structure consisting of a central nucleus containing the protons and neutrons, surrounded by orbiting electrons. Here is an example of a hydrogen atom. It has one proton, one neutron, and one electron. The proton and the neutron are contained in the central nucleus. The electron is in an orbit about the nucleus. To be charge neutral, an element must have the same number of electrons as protons. Each element has a unique number of electron-proton pairs that distinguishes it from all other elements. However, one element can have different numbers of neutrons, which are called isotopes. Where an atom has many electrons, they are constrained to be in certain fixed orbits, termed orbitals or shells. Here is an example of a sodium atom, which is a metal. A sodium atom has 11 protons, 12 neutrons, and 11 electrons. In the nucleus, we have the 11 protons and the 12 neutrons. And the electrons are arranged in shells about the nucleus as follows. 2 electrons can go in the first shell. 8 electrons can go in the second shell. Finally, 18 can go into the third shell. However, when we get to the third shell, we only have 1 electron left to be placed, so just 1 electron goes into the third shell. This situation characterizes metals. They all have only 1 or just a few electrons in their outer shell. In metals, the electrons in the outer shell, being somewhat shielded from the nucleus by the other complete shells, can gain enough energy to leave the atom, and because of this, they are termed free electrons. In some materials, the outer electrons can get enough energy